Hey guys, in this Chem tutorial 1.2, we are going to be talking about one of my favorite subjects, and that's matter. And matter matters, guys. In fact, matter matters really matter. Get it? What is matter? We kind of talked about this on our entry day, but the actual definition for matter is anything that takes up space and has volume. So, I put a bunch of objects on our screen so we could kind of talk about it, but some things that are matter would be like an atom. That is something that is matter. Bricks, that's something that's matter. Couple things that are not considered matter. Oh, air. Air, believe it or not, is matter. It's made up of mostly oxygen and nitrogen, but there's a lot of other things in it like carbon dioxide and hydrogen and some things that are not matter. Your feelings. Your feelings don't matter, guys, because they're not really matter. Your feelings don't have mass and they don't take up space except for in your head. The sun, light. Light is not a form of matter. Light is something that you'll learn more about in physics, but light is not. So if we had to break matter down into the smallest piece, we would find the atom. Okay, and the atom is essentially known as the building block of matter, and that's really what we study mostly in chemistry is this little guy, the atom. It's composed of a proton, neutron, electron, and we'll talk more about those later. But the cool thing about matter is that it can be combined together. So here we have lots of atoms that are combined together through little bonds right here. And if we take this molecule and we bond it to other molecules, we might get kind of a massive molecule. And if we take those molecules and combine them with other massive molecules, we can end up getting an actual physical structure, like a piece of cloth. So everything that we can touch around us and we can see is essentially made up of these little atoms. So one thing that we're going to learn today is how matter is classified. How do we break down matter? Well, there's two main categories. The first category are pure substances. Okay, and that's what we're going to talk about first. The second category of matter are mixtures. Okay, and so just a quick introduction to pure substances is that essentially pure substances are made up of only one type of chemical. Okay. Pure substances are made up of only one type of chemical. Mixtures, however, are just like the name. They are a mixture of two or more chemicals. Okay. Now, we can actually break this down into smaller categories. Okay, so a pure substance can be broken down into an element or a compound. Okay, so essentially an element is when that one type of chemical is made up of one type of element. We know the periodic table of elements has lots of elements on there, and so something we categorize as an element is where it's only made up of one type of element. Okay, so this piece is made up of gold, so it's made up of only the symbol Au, or that's the symbol for the element gold. Okay. However, a compound is still one type of chemical, but it just so happens that that chemical is actually made up of more than one element. For example, salt. Okay, salt is made up of an element called sodium, which is Na, and an element called chlorine, which is Cl. And it's Cl and Na, and they're bonded together, so they're only one thing. NaCl is not Na separately floating around and Cl separately floating around. It's one compound. It's one chemical, sodium chloride. Okay. So if you see the symbols right next to each other, or you see the names right next to each other, like sodium chloride or NaCl, that means it's bonded together and it's only one type of chemical, even though it's made up of more than one type of element. Okay. Water is another example of a pure compound. Water is made up of two types of chemicals. It's made up of hydrogen It's actually made up of 2 hydrogens bonded with 1 oxygen. That's where we get the formula H2O. So this compound, it's only made up of water, okay? So this whole glass just only has water in it, so it's still a pure substance. But that chemical that makes up the pure compound is made up of multiple different types of elements that are bonded together, okay? Now mixtures can be broken down into a mixture that is evenly mixed and a mixture that is unevenly mixed, okay? So a homogeneous mixture is something that looks even throughout, and a heterogeneous mixture is something that looks uneven. So let's break down what I just told you a little bit further. So going back, remember there's 2 main categories. There's pure substances and there's mixtures. Pure substances are made up of only one chemical, okay? One chemical. So, for example, this is a block right here of sodium. I know it looks like wood, but it's actually a block of sodium. The only thing that it has in it is just the chemical sodium, okay? So this particular pure substance we would classify as an element because it only has one element that makes up that chemical. This next picture shows chlorine gas, okay? This gas, we can see, has a chemical, and there's only one type of chemical in here. We can see it. It's repeated over and over again. This chemical is 2 chlorines bonded together. Now, how many elements do we have in this chemical? We only have one element, right? Chlorine is the only element in there. Even though there's 2 chlorines, we still only have chlorine, okay? We don't have any other element. So we still classify this as a pure substance, and underneath the pure substance, we would classify it as an element, okay? Now, next, I'm showing you a block of salt. Salt is a chemical that is Na and Cl combined together, okay? They're bonded together to form that one chemical NaCl, or sodium chloride. Since this has 2 elements that make up the compound, I call it a compound instead of an element. Now, looking at these examples, which ones are pure substances? Well, we can tell that B is made up of one chemical, right? It's the same chemical over and over and over again. So this is definitely an element. This second picture over here, C, is again, it's made up of one chemical that's repeated, right? The same chemical we see over and over and over again. So it's also an element. But the first picture, A, has a chemical with 2 reds and a chemical with 2 blues. So these are 2 different chemicals. This is chemical A and this is chemical B. So it is not a pure substance. Now let's look at these 2. Did I write E for pure substance? I'm so sorry. I should have wrote P. I don't know what I was thinking. Okay, so now let's look at these 2 pure substances and let's figure out which ones are elements and which ones are compounds. Remember, elements are only made up of one type of element. In picture B, I see that we have the red element that is used twice in the compound, but I only see the red element, which means this is also classified as an element. But picture C, I can see that this chemical here is made up of the element that's blue and the element that's red. So since I have 2 different elements that make up the chemical, I call it a compound. Okay, now let's move on to mixtures. Remember, there's 2 types of mixtures. One of them is evenly mixed and one of them is unevenly mixed, okay? The cool thing about mixtures is that you know it's a mixture if you can physically separate it, okay? Pure substances, you cannot physically separate because it's all the same thing. But a mixture, you can physically separate. Homogeneous mixtures may look like you can't separate them. They may look like a pure substance, but it just means that they're mixed really, really well. They're still made up of different chemicals, okay? For example, air. Air is made up of nitrogen gas, which are 2 N's bonded together, and chlorine gas, which are 2 Cl's bonded together, and oxygen gas, bonded together with other oxygen gas. So we can see this is one chemical, this is another chemical, This is a third chemical. So it's a mixture of elements. It's a mixture of chemicals. Okay? Even though air may look like it's all uniform, it just means that it's mixed evenly. Heterogeneous mixtures are mixtures where you can obviously see the separate parts, like a chocolate chip cookie or iced tea, where you can see the ice and the tea, or granite or marble, where you can see the different parts of the rock. So here's an example. We have granite right here, and we can see all the separate parts in this mixture. So we would call this a heterogeneous mixture. Blood looks the same, right? It all looks even though when you zoom in, you know that blood is made up of red blood cells, and it's made up of white blood cells, and it's made up of the plasma. So it's a mixture, right? Because it's a bunch of different chemicals, but it looks like it's the same. So we call this a homogeneous mixture. And then this is an example of water with food coloring. So I know I have water, which is one type of chemical, and I know I have food coloring, which is a different type of chemical, so I know it's a mixture, but since it all looks the same, it is a homogeneous mixture. The cool thing about mixtures that I said earlier is that you can separate them, right? So there's two ways that we are going to practice in the lab separating out a mixture. The first is through filtration. A filter system allows the bigger particles to collect in the filter, and the liquid is going to be gathering on the bottom. So if you want to separate a chunky solid from a liquid, then you use a filtration system. But what happens if there's particles dissolved in liquid like salt, okay? You can't separate salt using a filter because the salt is so small. So you can do a system called vaporization. What that does is you put the liquid in here and the salt in here, and guess what happens to the liquid? The liquid will boil off as vapor. And what will be left in the bowl? It'll be the solid, right? So the salt can be left in the bowl and the water can evaporate. So this is one way to separate water from salt. And these are the last two separation techniques. We never talk about them and we don't do them in our lab, but you do need to be familiar that the word decanting and the word centrifuge or centrifugation are separation techniques, even though we don't use them. And this picture just kind of sums up everything we talked about in our video, in that elements, remember, are made of one element. Compounds are two or more elements bonded together. It's still the same chemical, but they're just bonded together. Homogeneous mixtures are evenly mixed. Heterogeneous mixtures are unevenly mixed. And that's it for this video. You can get started on your 1.2 skill check and have a great day because it matters.